Hello everyone. How's everyone doing? I hope everyone is doing great. So this video continue from the last video. So let's dive in. But before that, I want to make a notice that let's forget about the area in this point here. Not for entire video, but just only for this point. Why? Well, I'll tell you why. I want to introduce you a very just I'll tell you and then I'm telling you right away. So I want to introduce you a very special property of the integral, and so yeah, so I want to take on my time to introduce you that. So let's forget about the thing about area. So let's dive into the math. And so this is, -3. So integrating from -3 to 1. So this is the problem, kind of a last video, I kind of bring it up. And so let's evaluate this interval. And so it's equal to what? So again, we do the integral. So I get this one here, right? So evaluating from -3 to 1. And that is equal to 1 over 2 times 1 square minus 1 over 2 times -3 square. Well, that's equal to 1 over 2 minus 9 over 2 is equal to -8 over 2. That means -4. All right, we clear. All right, so for this definite integral, this one is equal to -4. I'm sorry, -4. All right, and so now is there another way for solving this? Funny question. Is there another way for solving this? The answer is yes. I'm going to show you how. All right, so let's draw a number line. All right, and this is -3. This is 1. Now between -3 and 1, there are 3 integers. -2, -1, 0. All right, and so I'm having 3 fingers in here, and these 3 fingers will represent my 3 numbers in here. So this one will be my I don't know what this one called, but it will be it will be 0, -1, -2. All right, and so what I'm going to do is to do eeny, meeny, miny, mo, and determine what number I'm going with. All right, so let's start.
2,000 years later.
Eeny, meeny, miny, mo. And so it turns out that I'm pointing that's this finger, and this finger is equal to -1. Sorry, it took me a long time to play this eeny, meeny, miny, mo, and I kind of forgot the number. And so I'm going to do the integrating. So now it's -3 to 1, right? So what if I break this one down? All right, so remember I touch on this finger. So I'm going to break down to evaluating from. So I'm going to highlight this. All right, so this 2 will be gone. So I'm going to doing the integration from here to here. Should be there right away. So from here to here, and then another integration from here to here. So this part here, so from -3 to -1 of x dx, this part here is belong to this guy, plus, right, I'm adding two of them together, right? So it has to be plus from -1 to 1. So there'll be this guy over here of x dx. All right, let's evaluate this. Is -8 over 2 is equal to -4. All right, so that's what I got, -4. Look at that, beautiful, right? And so, interesting, right? Because, well, previously we just do this integration normally, right? So we are just done this integration normally, and I got -4. If I break them up like pieces here, is also equal to -4. So what can I conclude? I conclude that this guy here is actually equal to this guy, which I rewrote there, right? So again, so I'm gonna rewrite this. So if I want to rewriting this guy here, right, f of x, so not f of x, but x dx is actually equal to, now through the game of Eeny, Meeny, Miny, Mo, that's the reason why I'm playing this game. I'm gonna call it number B. And the reason why I'm doing the game of Eeny, Meeny, Miny, Mo is all because I want to convince you that I don't know which one my fingers will land onto. But whatever that number is, this one is always hold true. That if no, so I'm just going to write this. I'm just finished writing this, right? Now, no matter what B is, so B has to be in between -3, and B has to be in between -3 and 1, and so this whole thing is always -4. Alright, so this brings out a very, 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 very cool property. So allow me to erasing this. So if I do have a number line, alright, of A to C. Now I need a B in between. So if there is on the number line, there exists a number B between A and C. Now the B doesn't necessarily has to be in the center or the middle of A and C. It can be at anywhere. It can be at here. It can be at here, right? So it doesn't matter anywhere. As long as it satisfies the condition of the B is in between A and C, then if I do the integration from A to C of any function f of x dx, I can always break it down to be A, right? And then dx, and from A to B, and then from B to C. So from B to C. And this one is always hold true. Always. And this is one of the very, very cool properties of definite integral. Now back to the previous video that we talked about definite integral, that talk about the area under the curve, right? So I'm gonna remind you, I'm gonna draw and remind you this, right? Remember we talked about, well, y is equal to x, right? And this area here, right? And remember we talked about, well, this area here for sure is much less, the negative side of the area much bigger than the positive side of the area, right? So if I assuming this one is -c and this one is area is equal to d, then the area is -c plus d, which is area is negative. And of course we know area can never be negative. The only way we can find the true area for this is we have to convert the c, the negative c, to positive c in order for us to solve the area correctly. So how can I converting the c to d? The negative c, c to d. But how can I convert the negative c to positive c? Previously, we don't have this property. We don't know how to do it. But now we have this property and I can fairly doing it, right? So the way we're going to do is, again, we're going to break it down. So if I have to evaluate this function, so remember that I have to let's calculate this true area by using pure Pythagoras theorem. Okay, not Pythagoras theorem. What am I talking about? How is it calculate the area by using pure Pythagoras theorem? Don't listen to this guy. So if I have to calculate the true area, so I have to calculate the area on each triangle, right? So this area here, right? So this area here is equal to, so the C, let's calculate the area C, all right, which is this part, all right. So this one is the area C. Now the area C, of course, is equal to 1 over 2 base times height. Base times height, base is equal to 3, height is equal to 3, is 9 over 2, right? So the area D over here, which is this one, right? So area D, so is equal to 1/2 base times height. So we got 1 over 2, base is 1, height is 1, so it's equal to 1, 2. So the true area, right, is equal to C plus D is equal to 9 over 2 plus 1 over 2 is equal to 10 over 2 and is equal to 5. All right, easy, simple. So this is how I calculate the true area. And now I'm going to use this property to solving this problem here. All right. So, but again, take note in case that definite integral always bring up negative sign. So we have to add another negative sign to turn it to positive. So what do I mean by that? So again, I want to find the area under the curve between -3 and 1 of this function of, sorry, what am I writing? Between the function of y is equal to x, right? So I'm going to break it down, all right? So I can see it make a triangle at this point here. So I'm going to say, well, it breaks down from so 0 to, from -3 to 0, x dx, right? Plus from again from 0 to 1, x dx. Now, very importantly, I have to add a negative sign there, because if I don't add, the area still comes out, this one still comes out negative. So I have to add a negative sign so that it becomes a positive. So let's solve this, all right? And so again, so let's solve it exactly the way we solved it previously. So it's been 1 over 2, right? So evaluating from -3 to 0 plus, x squared. And sorry, not negative, what am I writing? So 1 over 2 x squared, this one here, 1 over 2 x squared, right? Evaluating from 0 to 1. All right, so now it's equal to -1 over 2. So 0, I'm going to ignore that. So let's just don't be lazy. So -3 squared, right? Plus 1/2 1 squared minus not that one, minus 1/2 times 0 squared. All right, so when you're going to calculating that, well, I'm going to take out my negative sign. So I have negative here, negative plus positive. So let's don't be lazy. No one can see it. No one can see what I mean. No, some of you guys can see it, but again, I want to make myself clear. All right, so like this, all right, plus 1 over 2. All right, so I'm gonna allow me to clear this one out, right? Because again, 1/2 plus times 1 is equal to 1/2. All right, so again, you can see negative with negative is turned into positive. So 1/2 -3 squared. This one is 3 squared here. Allow me to use a 9. Plus 1/2 is equal to 10 over 2, which is equal to 5. Now, exactly what we can calculate as a true area here. So the way we're going to solve it is, again, we're going to break the areas up, right? We know it's one is negative area, and so we're going to break it up, and we're going to use the convert the negative sign back to the positive, and then we can solving it. And so yeah, so it's the same problem in here. So I'm not going to solving this, but again, it's going to be work out the same way. So again, so if I have to evaluate from this one is 1, for example, and this one is 3, now we clearly see this one is much bigger than this one. Of course, you know, this one is for sure, this one is negative side, this one will be a negative area, right? So this area will be negative. So break it down. Sorry, this one has to be -1. Break it down. So I'm evaluating from this to this, right? I'm reevaluating. Oh my god. I'm reevaluating from here to here, and I'm gonna say minus area. So put the negative sign in front of it, and then you evaluate it. And so this one is just area itself. So don't worry about this one at all. So gonna solve exactly the same way. You can try it by yourself. So this function f of is y is equal to x. You can try to evaluating this one by yourself. So try to find the area of this. All right. And so I can post the answer on the description. But again, try your best to solve by yourself and see if you can get it. All right, so now I want to show you using this property is very, very helpful in order to solve this problem. And this will be my last problem of the video. And yeah, I hope you're enjoying this. So I'm gonna add, oh my god, what am I drawing right now? Oh my god, look at my line. So imagine, I know my drawing is really bad though. Imagine this one is y is equal to absolute value of x. All right, and I want to evaluating from -3 to 1. I like -3 to 1, probably. Now, how can I solve this? Okay, so but then, all right, now to deal with absolute value is very, very tricky. So if you remember last time I did walk through with you about that one, you can use that idea to solving. And again, I'm going to walk through with you again. All right. And so solving with absolute value, always have to remember that if my interval is all in the negative side of the x, then the x then is turned to negative x. So meaning if all my interval is in negative side, that means the x is turned to negative x. If all my interval is in the positive side, that means my x is positive x. All right. And so in order to solve this, so again, we're gonna break it down again. So remember, I'm gonna break it down. We kind of walked through this problem on the last video, but again, for this one, I cannot write x anymore, but I have to write negative x and plus, right? So from 0 to 1, x dx. All right, and we gotta work out the same way. And so I believe is still equal to 5. All right. And you can work out the math if you want to, but again, it's equal to 5. And so yeah, so this is the way to solve this property, applying this property, and why it exists. See you on the next video. Bye. Someone's calling me right now, but bye. Thank you so much for watching.
Hello?
I have just one question for you. Are you ready
to do integral calculus?
Bruh.